Welcome back to Low-Level Programming Crashcasts. I'm Sheila, and I'm here with Victor to dive deeper into the fascinating world of computer architecture. Before we begin, we'd love to hear from you. If you're enjoying the show, please take a moment to rate us on your favorite podcast platform. It really helps us reach more learners like you.
That's right, Sheila. Your feedback means the world to us. Now let's continue our journey through the Understanding Computer Architecture chapter. Today we'll be exploring CPU components and operation.
Excellent, Victor. But before we dive in, I have a tricky quiz question for our listeners. Here it is. If one CPU has a clock speed of 3 GHz and another has a clock speed of 2 GHz, is the 3 GHz CPU always 50% faster in real-world performance?
Ooh, that's a great question, Sheila. It really gets to the heart of some common misconceptions about CPU performance. I'm sure our listeners will be pondering this as we go through today's topic. Let's break it down a bit without giving away the answer. What do you think are some factors that might influence the answer?
Well, I imagine there's more to CPU performance than just clock speed. Maybe things like the CPU's architecture or the type of tasks it's performing could play a role. But let's not spoil it for our listeners. We'll reveal the answer at the end of the episode.
Absolutely. Now, before we dive into the nitty-gritty of CPU components and operation, let's quickly define some key terms. Sheila, could you give us a brief explanation of what a CPU is?
Sure thing. CPU stands for Central Processing Unit. It's often called the brain of the computer, responsible for executing instructions and performing calculations. Is that a good starting point, Victor?
That's a perfect start, Sheila. Now, let's break down the main components of a CPU. The three primary components are the Arithmetic Logic Unit, ALU, the Control Unit, and the registers. Can you tell us about the ALU?
The ALU performs arithmetic and logical operations, right? So it handles things like addition, subtraction, and comparisons. But I'm not sure about its exact role in the CPU's operation. Could you elaborate on that, Victor?
Absolutely. You're on the right track. The ALU is indeed responsible for all arithmetic and logical operations. Think of it as the CPU's calculator. When the CPU needs to perform any mathematical or logical operation, it sends the data to the ALU, which then carries out the operation and returns the result.
That makes sense. So what about the control unit? What's its role in the CPU?
Great question. The control unit is like the conductor of an orchestra. It coordinates the activities of all other components in the CPU. It fetches instructions from memory, decodes them, and then directs the other components to execute these instructions. It's responsible for maintaining the order of operations and ensuring that everything happens at the right time.
I see. And the registers? Are they like the CPU's short-term memory?
That's an excellent analogy, Sheila. Registers are indeed like the CPU's short-term memory. They're small, extremely fast storage locations within the CPU itself. The CPU uses these to store data that it's currently working with, which allows for much faster access than if it had to retrieve the data from main memory every time.
This is fascinating. But how do all these components work together to actually process instructions?
That's where the Fetch-Decode-Execute cycle comes in. This is the basic operational cycle of the CPU. First, the control unit fetches an instruction from memory. Then it decodes the instruction to determine what operation needs to be performed. Finally, it executes the instruction, which might involve the ALU performing a calculation, data being moved to or from registers, or other operations.
That sounds like a lot of steps for every single instruction. How does the CPU manage to do this so quickly?
Great observation. This is where we start to see more advanced concepts come into play. One key technique is pipelining. Imagine a kitchen preparing meals. Instead of completing one meal entirely before starting the next, different stages of meal preparation can happen simultaneously for different orders. Similarly, the CPU can overlap the stages of the Fetch-Decode-Execute cycle for different instructions.
Oh, I see. So while one instruction is being executed, the next one could already be in the decoding stage, and a third one could be being fetched.
Exactly. This significantly increases the throughput of the CPU. Modern CPUs take this even further with concepts like superscalar architectures, which can execute multiple instructions simultaneously, and out-of-order execution, which can rearrange the order of instructions for optimal performance.
Wow, that's incredible. It seems like there's a lot more to CPU performance than just clock speed. Speaking of which, I think it's time to reveal the answer to our quiz question. Victor, would you like to do the honors?
Certainly. The answer to our quiz question is no. A CPU with a 3 GHz clock speed is not always 50% faster in real-world performance than a 2 GHz CPU. While clock speed is important, many other factors affect overall performance, including the CPU's architecture, the number of cores, cache size, and the nature of the tasks being performed.
That makes so much sense now. To wrap up, let's summarize the main points we've covered today. We learned about the main components of a CPU, the ALU, control unit, and registers. We also discussed the Fetch-Decode-Execute cycle and how techniques like pipelining help improve CPU performance. Finally, we touched on some advanced concepts like superscalar architectures and out-of-order execution.
Excellent summary, Sheila. Understanding these concepts is crucial for anyone diving into low-level programming. They provide insight into how our code is actually executed by the hardware.
Absolutely, Victor. And to our listeners, we hope you found this episode informative and engaging. If you did, please consider supporting us. Visit crashcasts.com to join our Discord community, support us on Patreon, or subscribe to the podcast. Your support helps us continue creating content to help you on your low-level programming journey. Until next time, happy coding.